So now we're going to draw a trapezoid according to the definition of a trapezoid. And so we just talked about that a trapezoid is a quadrilateral that has at least one set of parallel sides, not lines, that has at least one set of parallel sides. Okay, so this is going to be our definition of a trapezoid, and we're going to use this definition to draw one. So to draw a shape, it's always good to have some sort of straight edge. So I'm going to use, oh my gosh, I just lost the name of this. It is not a root. I really just lost the name, so hopefully it'll come back to me in a minute. But I'm going to use this because I'm also going to be able to measure the angles of my trapezoid, and that's going to be kind of the next thing that we do once we've drawn it. So, okay, I need to have 4 straight sides, and I know that I need to have at least one set of parallel sides. So when I go to draw a trapezoid, I'm going to start by making one line. And I'm just going to start it here. I'm just going to end it there. Okay, so there's my first line. Now, I'm going to draw my second line here. Okay, so I know already I'm starting to create a trapezoid because I have one set of parallel lines. These 2 lines are parallel. So now I'm going to go and I'm going to just create there we go. I have created a trapezoid right here. That is my trapezoid. And I can see that I have my 4 sides. 1, 2, 3, 4. And then I can see that these 2 lines are parallel to one another. So I have now drawn a trapezoid. Okay, so your trapezoid could look different. If you were drawing a trapezoid at home, your trapezoid might look different than mine because, again, trapezoids are quadrilaterals, so they have to have 4 sides, and then at least one pair is one pair of sides is parallel. So there are different types of quadrilaterals out there, and we're actually going to explore that in the problem set. Before I move on to problem set work, though, I do want to show you something. So earlier I drew another example of a trapezoid. So I'm going to show you that one. And I went ahead and I measured the angles of my trapezoid. So, which actually, I might not want to do that yet. I'm going to come back to that. Okay, so with trapezoids, one of the things that we learn in this topic is how to measure angles, because our inside angles of our trapezoid should all equal 360 degrees. And so here we go. I'm going to measure my angles. So what's really great is right here you can see there's this little teeny circle. This little teeny circle helps me correctly measure the angles of my trapezoid. I place that little teeny circle at where 2 of my lines meet. Okay, so at like a vertex. So if I wanted to measure this angle here, this bottom angle, then I'm going to take this. I'm going to place that circle right where these 2 lines meet. Now I'm going to line this up. I should show you. There's also a thin line here. This is going to be how I make sure that everything is correct when I go to measure. So my line here is going to line up on this line. Protractor. It's called a protractor. It just came to me. Okay. So I'm making sure that my lines are lining up. And so then I go to read this angle. Now, this angle is larger than 90 degrees, okay? I know that because a 90-degree angle would look something like that, okay? So I can see that this angle is larger than 90 degrees. So therefore it's obtuse. So do you remember that? So obtuse angles are greater than 90 degrees. So when I measure and I get my protractor set up again, I'm going to read the bottom numbers, okay? Because the bottom number is where it shows me that it is larger than 90 degrees. You can see there's a bottom number and then there's a top number. I need the bottom number. Okay, so if I'm reading this, this says it's not quite 110, 108, 108 degrees. Okay, now if I go and I measure this angle, I can see that this also is larger than 90 degrees. So I'm going to line everything up. I'm going to read again this time. I'm not going to read my bottom number. I'm going to read my top number because I need the number that's larger than 90. So here's 110, 11, 12, 13, 14. This looks like this is about 115 degrees. Okay, and now to measure these angles, I'm going to flip my paper. I'm still and I can see, okay, here, if this were 90 degrees, this would be like this, let's say. So I can see that this is less than 90 degrees. Sorry about all the flipping. So we have a name for those angles. An acute angle is less than 90 degrees. Okay, so I'm going to go back. So if I'm reading an angle that's less than 90 degrees, try and line up the best I can here. Okay, so then I'm going to use my numbers on top. Okay, so let's see, I'm at 70, 71, 72, 73. And then if I'm reading this angle, I can see that's also an acute angle. So this is right about 65. Okay, so one thing when we are looking at measuring angles is there's a couple things that we need to know is all of our inside angles should equal 360 degrees, but we have angles that are going to match up. And in a minute, I'm going to take my other drawing. You know what? Actually, no, let's not do that. I'm going to cut this one out to show you. So I have my angles. This is angle A, this is angle B, this is angle C, and this is angle D. So in this, all of my angles should equal 360 degrees. Okay, so what I can do is I can actually look at angle A and angle C. So angle A plus angle C should equal 180 degrees. And then angle B plus angle D should equal 180 degrees. And then altogether, that would equal 360. Okay, so if I'm looking at angles A and C, I have 108 plus 73. And I think this is going to be a little off. 8 plus 3 is 11. 8. So we have 181 degrees. That 1 degree difference could be in my measurement. It could be in my drawing. And then over here we have 115 plus 65. And that was 180 degrees. Please go sit down. 1 second, guys. Go. Okay, so that equaled 180 degrees exactly. Okay, so we can see that this does work. So I am going to take this one that I drew earlier. So this looks different than my one that we just did, but I want to show you how these angles line up. So I already drew this one and I measured. So I have my 100 degrees down here, 80 degrees up here. Give me a second. Okay. Hi, bud. Hey, recording a video. Give me a minute, okay? Okay, guys, so I'm going to cut this one out, and I'm just going to cut along my lines. Okay, so I've now cut out my trapezoid. Make the scraps. And I'm going to cut this into 4 pieces. The first cut I'm going to make is like this, and I'm making a squiggly cut. Okay, and then I'm going to do that one more time. So I'm kind of separating my angles. Okay, life with children, guys. Okay, give me a second. There you go. Okay. All right, so I'm going to cut between these angles as well. Okay, so now I have my angles. So here's what's really kind of cool, I think, is that if I take my angle A and my angle C, let me see, I always kind of, there we go. And I put angle, let me do it this way, and I put angle A and C together. And so that way my angles match. I've just created a straight angle measuring 180 degrees. And I can take angle B and D, and I can do the same thing, except for I didn't draw my angle. There we go. B and D, and I put those together, and I have just created straight angles, which both equal 180 degrees. Okay, so then we know all together, if we were to put this back together, our trapezoid would equal 360 degrees. So what I just did here was what I showed you here when I took those angles and added them together, and took those angles and added them together. Okay, so if we're looking at our angles, we have 4 angles, but each pair of angle adds up to 180 degrees. Okay, so we're going to go ahead. This was part 2 of the video. I'm going to come back with the problem set. And so that way you can see some of this measuring and this measuring work put to good use. And you can also see some different types of trapezoids. Okay, thanks.